Hello guys, welcome to Unacademy Studios Bridge. Continuing with gate questions series, we have already completed, the axial loading. We have already completed the torsional loading, and we have even completed in the third part of the series, we have even completed the shear force and bending moment. But for the shear force and bending moment, we have completed only the load part. Now in this current session, we are going to complete the stress part. That due to shear force and due to bending moment, what are the stresses that will be developed? So let's go ahead and do this. Just in case if you're new to me and I'm new to you, I'm Marut Tiwari and I did my master's from IIT Kharagpur. I've been a recipient of multiple awards there and I have cracked GATE for multiple times with under 1000 rank, and I'm also an author of the book GATE in 75 Days. You can follow me on Unacademy. On Unacademy, you can follow me on this particular link, because on Unacademy I'm going to take number of free special classes and I'm going to take number of courses for GATE 2000, number of crash courses for GATE 2020, and also number of full-length courses for GATE 2021 and also for ESE 2020 and 2021. So as of now, I'm a proud educator of Unacademy. Unacademy, like me, Unacademy is having a pool of very good educators. There are so many reasons that I can tell you to be associated with Unacademy, that you should be doing your GATE preparation with Unacademy only, that you get a flexible schedule, you get language of your choice, you can attend the session in English, you can attend the session in Hindi, and you can do unlimited practice. You can watch the sessions as many times as you want. Then my dear friends, while attending the live sessions on Unacademy Learning app, you can chat with the educators and you can participate in interactive polls, and you can learn anytime and anywhere. So there are so many reasons I can give to you. One of the biggest reason is the cost effectiveness of learning from Unacademy. You don't have to bear any travel expenses, you don't have to bear any hostel and room rent and everything. Wherever you are staying, you can learn from there only. You can go for 12 months package. 12 months subscription fees is 25,000 and 24 months subscription fees for GATE is 40,000. But if you're going to use my code MTLive at the time of subscription, then my dear friends, this will come down. And by the way, even if you go for ESE subscription, you have the same structure. So this will come down if you use the code MTLive. Then my dear friends, this will come down by 10%. You'll get 10% additional discount, and 1 year subscription will cost you just 22,500 rupees, and 2 years subscription will cost you 36,000 rupees. If you calculate this on per month basis, it's going to come down to just 1875 rupees per month. And if you calculate 2 years subscription on per month basis, it comes down to just 1500 rupees per month. Now this is unmatchable. Particularly if you think about the quality that you're going to get here on Unacademy Learning app. I'm telling you that I'm going to teach live on Unacademy. And I'm going to take 4 to 5 subjects. I'm going to take engineering mechanics. I'm going to take mechanics of solids. I'm going to take theory of machines and machine design and fluid mechanics. And I'm going to teach them systematically, step by step, covering such a variety of problems that not even one single variety will be untouched. So just in case if you're preparing for GATE 2021, just in case if you are preparing for GATE 2021, my dear friends, make sure that you subscribe using the code MT Live to get 10% additional discount. And then, my dear friends, you have to do just one simple thing. You'll have to install the Unacademy Learning app, and you'll have to choose GATE as your goal, and then you're good to go. You're good to begin your preparation. Now let us go ahead and talk about the topic in hand. The topic that we have is what? The topic that we have is that we are interested in the stress now. And we are particularly interested in the bending stress, that due to bending, what will be the stress? You already know that in bending we have two possibilities. In bending we have two possibilities. One possibility is sagging possibility, another possibility is hogging possibility. In sagging possibility, left will be clock and right will be anti-clock. In hogging possibility, left will be left side, you will have anti-clockwise moment, and right side you'll have clockwise moment. Now in case of sagging moment, in case of sagging bending, topmost will experience compressive action and bottommost will experience tensile action. In case of hogging bending, topmost will experience tensile action. You see, it is stretching ahead, and bottommost will experience compressive action. Guys, naturally, if you have on one extreme you have compressive, on another extreme you have tensile, then naturally the stress is varying, and if the stress is varying, it must be zero somewhere. If on one extreme you have negative value, on another extreme you have positive value, then naturally it must be zero somewhere. That somewhere where the stress is going to be zero, that is known by the name neutral axis. So in case of sagging bending, topmost point will have maximum compressive stress, bottommost point will have maximum tensile stress, and in between somewhere the stress will become zero due to bending moment. That particular axis where the stress becomes zero is known by the name neutral axis. Let me help you visualize this. Let me just help you visualize this. Let's say we have a beam of rectangular cross section. Let's say we have a beam of rectangular cross section, and then, my dear friends, between topmost and bottommost fibers, topmost and bottommost surface, somewhere you can identify a surface at which stress will be zero, and this surface is known by the name neutral surface. This green surface that I'm shading right now, this is what you call by the name neutral surface. Alright, this one is known by the name neutral surface. Then what is neutral axis? Neutral axis is the line of intersection for any section with neutral surface. I repeat that this is any given section, this red one and the green one is representing the neutral surface. They both are going to intersect at a line, and that line is known by the name neutral axis of the respective section. Above neutral axis, you're going to have above neutral axis. Let me mark all these points by yellow. So above the neutral axis, all these points that I'm marking right now, here you have compression, 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 compression. So yellow is representing compressive action, and below the neutral axis you will have tensile action. Below the neutral axis, this sky blue thing that I'm marking here, below the neutral axis you will have tensile action. So sky blue is representing the tensile action. I hope now you understand this, that bending causes varying stress with maximum tensile at one extreme and maximum compressive at another extreme, and zero value exactly at the not exactly at the mid, but zero value somewhere in the mid, and that line where zero value takes place, that line is known by the name neutral axis. How about the value? How do we calculate the value? Value we calculate by using bending equation, and the bending equation is given as sigma by y is equal to m by I is equal to sigma by y is equal to m by I is equal to E by R. My dear friends, most of the times we will be interested in maximum value, and though you can calculate maximum value for any given cross section, but the most important ones are rectangular cross section and circular cross section. For rectangular cross section, maximum bending stress formula is 6m by bd square, and for circular cross section, maximum bending stress formula is 32m by pi d cube. So I quickly recapitulate everything. Due to bending, number one, sigma will develop. Number two, it will not be uniform. It will be varying with maximum compressive at one extreme, maximum tensile at another extreme, and zero value somewhere in between. Number three, that for sagging, top will have compressive and bottom will have tensile. For hogging, top will have tensile and bottom will have compressive. Number four, that at any general point stress value you can find out using bending equation. And finally, number five, that maximum value which will take place at topmost and bottommost can be calculated as 6m by bd square if it is a rectangular section, and if it is a circular section, then 32m by pi d cube. So this is what we have. Guys. There is just one more thing that you need to understand with respect to the maximum values. If you recall the maximum values, just now I told you the maximum values for rectangular section and for circular section. For rectangular section, the maximum value is 6m by bd square, and for circular section, the maximum value is 32m by pi d cube. I can manipulate them. I can rearrange them to be visible like this. I can rearrange this sigma max values to be visible something like this. Now if you compare this with standard axial loading formula, if you compare these sigma max formulas with standard axial loading formula, in which the basic formula for the stress we defined as load divided by area, then if you compare this, my dear friends, interestingly you see that you have sigma and sigma and sigma, and you have load and load and load, and in the denominator you have area here which is representing B into D. And though this one is not area, but nonetheless it is depending upon cross-sectional area only. It is depending upon the parameters belonging to cross-sectional area only. Like area is width into depth, so here also you have width and depth only. So this entire parameter in the denominator is depending upon this entire parameter here in the denominator is depending upon the cross section. All right, is depending upon the cross section. I'm sorry. This denominator is a function of only one thing, and that one thing is the cross section. Therefore, people named this as section modulus. People said that we'll call this parameter by the name section modulus, because it is depending upon section only, and we represent it as Z. So please do remember, as far as section modulus is concerned, for rectangle section modulus value is BD square divided by 6, and for circle, my dear friends, the section modulus value is pi d cube divided by 32. Just to compare these bending stress formulas with fundamental formula, you have load divided by area. So here also you have load divided by section. This is how you can remember them. Keeping all these things in your mind, let's go ahead and try solving some problems. As a very first problem, we have this 2003 problem. As the very first problem, we have this 2003 problem. Let me describe this problem at the very first. We have, guys, two beams. One is having a square cross section and another is having circular cross section. One is having a square cross section, another is having circular cross section, and they are subjected to same bending moment. So just keep this in mind. We have two beams. One is having a square cross section, another is having circular cross section, and they are subjected to same bending moment. Now if the cross-sectional area is equal, then they are asking that, maximum bending stress will be same in both the beams, or maximum bending stress will be more in case of circular beam, or maximum bending stress will be more in case of square beam. All right. So these things are given to you. Let me once again elaborate the problem very quickly. That the problem is what? Problem is, my dear friends, that we have a beam of square cross section, and we have another beam of circular cross section. We have another beam of circular cross section. Let's say dia is D, and this one is the beam of square cross section where we have A and A. So this is what we have now. This is what we have. Now it is given that we have same bending moment and we have same area. They are asking that which beam is going to experience more bending stress or which beam is going to experience less bending stress. This is what they are asking. So let us take the ratio. Square beam and circular beam. Let's represent a square beam by S and circular beam by C. So square beam is what? A square beam is going to have 6m by BD square, and circular beam, just now I told you the maximum bending stress formulas, 6m by BD square and 32m by pi d cube. So this one is 32m by pi d cube. Now m and m, they are going to get cancelled, and if you simplify this further, you'll get pi will go to the numerator, so you'll get, pi will go to the numerator, so you'll get 6 pi divided by 32, and then you'll get d by a cube. Now how do you get this d by a cube? How do you get d by a ratio? Basically, to get the d by a ratio, you need to equate the area, because it is given that we have the same cross-sectional area. It is given that we have the same cross-sectional area. So this will be equal. Now square beam is having a square and circular beam is having pi d square by 4. So from here you'll get d by a value as 4 divided by pi under square root. You can put this value. You can substitute this value here, and if you substitute this value here, then you will get 6 pi by 32, and d by a is nothing but 4 by pi power 1 by 2. You can calculate this. If I calculate this, let me pick up my calculator. So you'll have 6 pi divided by 32 multiplied by 4 divided by, I did something, 4 by pi power 3 by 2. What's happening? 4 by pi is this power 3 by 2 is this into 6 pi divided by 32. This is 0.8463. This is 0.8463. So you get sigma s divided by sigma c less than 1. That means sigma s is less than sigma c. So square beam is having lesser stress, and therefore square beam is safe. Circular beam is having more stress. So which option is correct? The second option is correct. That says circular beam experiences more bending stress. So second option is correct, and you get 2 marks. Now this 2017 problem is just a formality. It is very easy problem. It is very simple problem. That the problem says that you have a circular cross section of diameter d. You have a circular cross section of diameter d. They are asking the ratio of second moment of area. Second moment of area means moment of inertia. Second moment of area means moment of inertia. So they are demanding the ratio of moment of inertia and section modulus. Moment of inertia and section modulus. This is, as I said, this is a very simple problem. For a circular section, they are asking ratio of moment of inertia and section modulus. Moment of inertia value for circle is pi d power 4 by 64. I just hope that you know about it. If you know, good for you. If you don't, no problem. Do remember it from now, that for a circle, moment of inertia value is pi d power 4 by 64, and section modulus value, I told you, for circle, I told you the section modulus value pi d cube by 32. So we can put pi d cube by 32. Now pi and pi, they are going to kill each other. Pi and pi, they are going to kill each other. D cube and 4 almost killed. Only 1d is remaining. And 32 and 64, this will have 2 remaining here. So this ratio you'll get simply as d by 2. Simply as d by 2. First option is the correct one. Now let us go ahead. From this particular topic, bending stress, not many problems have been asked as far as GATE is concerned, but some very good problems have been asked nonetheless. For example, this particular problem. This 2005 problem is one typical problem, one very good problem. This 2005 problem. Let me first of all describe the problem itself. The problem says that you have a cantilever beam loaded as shown in figure, and it has a cross section which is square, 10 mm by 10 mm. So beam is given and its cross section is given. Beam is given here and cross section is given here. Alright, beam is given and cross section is given. This entire information is given. Further, the examiner says that consider only bottom fibers. Now notice this word here, consider only bottom fibers. And then at bottom fibers, bending stress will vary according to which figure. So consider only bottom fiber, this bottom fiber, And at this bottom fiber, various points are there. So if you just calculate the bending stress at all those various points of this bottom fiber, then how that value of sigma at this bottom fiber, whatever value of sigma is there, how that value of sigma can be plotted and how that plot is going to look like. Let us go ahead and try solving this. Let us go ahead and try solving this. This can be solved very easily if you just use everything that I told you. I have in all the sessions that I have covered so far, whether it was axial loading or torsional loading or shear and bending diagrams or even the bending stress topic, every single time I told you just 3-4 things, and I told you that none of the problems is going to be out of these 3-4 things. So what is the thing that we are going to use here? You see, bottommost fiber means maximum stress. Due to bending, you'll have maximum stress at bottommost and topmost. And for a rectangular section, you already know the maximum bending stress formula. For a rectangular section, you already know the maximum bending stress formula. The maximum bending stress formula for a rectangular section is 6m divided by BD square. Now here you have B and D both 10 mm and 10 mm, 10 mm and 10 mm. So B and D both are 10 mm and 10 mm. So you will get 6 into 10 raised to minus 3 m. This is the bottommost fiber bending stress value. This is the bending stress value at the bottommost fiber. Now you can put the m value for any given section and you'll get the bending stress value at the bottommost fiber at that particular section. Alright, so this is what we have here. Now guys, you think about the bending moment, because now we know the bottommost fiber bending stress value in terms of m. In terms of m. So we know the maximum bending stress value in terms of bending moment. Now bending moment is what? If you think about any section between B and C, there is absolutely nothing on either side. If you have already watched my previous sessions, then you know either side is one powerful concept and you calculate each and every load from either side. So anywhere between B and C, you are getting bending moment value 0. And if bending moment value is 0, then sigma max will be what? Then this sigma max value will be 0, isn't it? So this sigma max value taking place at bottommost point will be 0. But incidentally, between B and C, examiner is not even giving you a chance. Examiner is saying that, okay, you calculated 0 value between B and C. I welcome you. All the values, all the options are having 0 values between B and C. So now you'll have to move on to any section between A and B. Any section between A and B you take, and my dear friends, the bending moment value, once again, if you calculate from either side, ek taraf, from one side, whatever forces are there, you consider all of them. Then you have the bending moment value in AB segment as 10 multiplied by x. So in AB segment, you have bending moment value as 10 multiplied by x. If you put it here, 10 multiplied by x for AB segment, then you'll get 10 multiplied by x if you put for AB segment, if you put the bending moment value 10 multiplied by x, then this sigma max value you'll get as 6 into 10 raised to minus 2x. Now this is what? Linear or parabolic? 6 into 10 raised to minus 2 multiplied by x is what? Linear or parabolic? Naturally it is linear. So if it is linear, then either Option A is correct or option C is correct. Because between A and B, here you have linear variation. So sigma max you are getting as linear function of x. Now, how do we know that whether first option is correct or third option is correct? Just put the x value 1 meter. Just put the x value as 1000 mm. So if you put the x value as 1000 mm, then you will get, if you put the x value as 1000 mm at A, then you will get 60 megapascal. And this is how option A is correct. So I just hope that you understand this. I am once again clarifying that I did not use any new concept here. I did not use any new concept here. Guys, whatever I told you, 6m by bd square, using the same concept, I solved it just like that. Now let me take you to this particular problem they asked in 2006. This is a very simple problem. This problem says that we have a simply supported beam. Okay. We have a simply, what the hell? We have a simply supported beam, length is 6 meter and dia is 75. Dia 75 means it has circular cross section. And it is subjected to a UDL of 1.5 kilonewton per meter. Then what is going to be the maximum value of bending stress? This is what we want to calculate. This is what we want to calculate. Let us go ahead and try solving it. Guys, we have a simply supported beam, and that simply supported beam is subjected to a UDL of 1.5 kilonewton per meter. The length is 6 meter given to you. For this beam, if you have watched my previous session, I proved that for this beam, maximum bending moment will be omega L square by 8. Omega value is 1.5 and L is 6 here. So if you simplify this, you will get 6.75 kilonewton. 6.75 kilonewton meter. Now, they are asking the maximum bending stress and they are giving you circular cross section. They are giving you circular cross section with 75 mm dia, and they are asking the maximum bending stress value. So what is the maximum bending stress formula for circular cross section? For circular cross section, I told you the maximum bending stress formula as 32m by pi d cube. For circular cross section, I told you the maximum bending stress formula is 32m by pi d cube. So you can go ahead and you can use, in our current problem, you can use this 32m by pi d cube. M value is anyway known to you. M value is 6.75 into 10 raised to 6. Why 10 raised to 6? Because I'm changing kilonewton to newton and meter to mm. And then you have dia is nothing but 75. If you calculate this, you will get 162.98 megapascal. So this is what you get, and this is how you get 2 marks. Now let us try solving this 2008 problem that they asked for 2 marks. This particular problem they asked, this is a good problem once again. This is rather a good problem once again. We have this load F acting and the cross section is given to you. This is the cross section. Okay, this is the cross section here, which is the square cross section 2b and 2b. This 2b by 2b square cross section is given to you. This square cross section is given to you. Now in such problems where load is not acting at the centroid, then the very first thing that you got to do is you will transfer the load to the centroid. At the very first of all, you will transfer the load to the centroid. Now if you will transfer this load to the centroid, then you will get two things. You will get F, of course, and you will get F multiplied by L minus B. F multiplied by L minus B. You'll get F multiplied by L minus B. I need a little more space. So guys, once you transfer it, you'll get two things. You'll get F and you'll get F multiplied by L minus B. And now you focus only at this much part. Why? Because this corner P is available at this vertical column, not at this horizontal frame. So that corner P is available at that vertical column. Therefore, now you focus at this vertical part only. Now you focus at this vertical part only that I'm shading right now. This part, you focus at this particular part. Okay, you focus at this part. Now this part is subjected to what? This part is subjected to what? This part is subjected to two things. One is axial tensile load. One is this axial tensile load, which is nothing but F. Another is bending moment, which is nothing but F into L minus B. So if you focus at only this vertical part is subjected to two things. One is axial tensile load F, and another is this bending, which is bending moment is F into L minus B. Now you tell me, due to this axial load, what will happen? Due to this axial load, naturally here you'll have some tensile action. So there will be some, due to axial load, there will be some tensile action. And due to bending moment, what will happen there? Due to bending moment, if you notice, and if you just follow the line of action of the bending moment, then due to bending moment, at P, you can very clearly see some tensile action. At Q, you can very clearly see some compressive action. At P, you can see some tensile action. At Q, you can see some compressive action, and you have this axial load also. So here you have some axial load and you have some bending moment, and net stress is going to be, net stress at P is going to be the stress due to axial loading at P and the stress due to bending at P. Incidentally, due to axial loading also, it is tensile at P, it is tensile at P, and due to bending also, at P it is tensile, at Q it will be compressive. So therefore both are tensile and tensile, that's why I'm adding them together. Now due to axial loading, simply it is going to be load divided by area, and due to bending for rectangular cross section, the value is 6m divided by B into D square. Now load is F and area is how much? Area is 2B into 2B. 2B into 2B, which is 4B square. Area is 2B into 2B, which is 4B square. And M is what? M is F multiplied by L minus B, and B is nothing but 2B, and D is also 2B. You can simplify this, and once you simplify this, you will get the final answer. Congratulations, you get 2 marks. You get 2 marks. So this was the end of this particular problem, and that's how we conclude the session. Thank you very much for watching the session. I just hope that you are enjoying the session and you are effectively quickly revising the things, and you're gearing up for GATE 2020. All the very best. Just make sure that in the description you go and you fill a query form, just in case if you have any query, and just in case if you want to add some suggestions for Unacademy, then in descriptions page, in the description of the video, you have a link where you can fill that form. That query form is there. You fill that form and submit it and hit the bell icon to keep receiving the notifications of my videos. And my dear friends, particularly those of my friends who are preparing for GATE 2021, go ahead, subscribe, because I'm going to teach live on Unacademy, not one subject, not two subjects, but all the way 4 to 5 subjects. And I'm myself going to take a guarantee of 40 to 50 marks as far as GATE 2021 is concerned. So use my code MTLive to subscribe for the things. I'm going to teach 4 to 5 subjects very systematically and very conceptually, starting from basics. So I just hope you enjoyed the session. Thank you very much once again.